Good morning, good afternoon, and good evening from wherever you are in the world. Welcome back to Industries Live. This is the season 2 premiere, as somebody said to me before, which I'm very excited to be joining you here from Seattle, Washington. My name is Michael Schmidt. I look after industry partnerships here at AWS, and I'm joined by my friend Patti Carroll. How are you, Patti? Good morning.
I'm doing great this morning. Thanks, Michael. Hi, everyone. Should I go ahead and introduce myself?
Go for it, Patti. Go for it.
Sure. I'm the go-to-market lead for agriculture at AWS, and I'm super excited to be on here today.
Awesome. Well, welcome. Patti's also in Seattle, Washington, but she's over the other side of town. Not very often we have the two hosts in the same city. Welcome to Series 2 for Industries Live. And we celebrated our first year anniversary at reInvent this year. If you haven't watched the show, we had a fantastic live show at reInvent where we had a whole bunch of interesting partners along to talk about what they're seeing in the industry and what they're seeing in their businesses and how they're what's happening with their customers. So encourage you to watch that episode online. This is the 1 year anniversary today of the streaming show, which is, again, I said before, the season 2 premiere, as somebody said before. We're very excited to kick off another year, 2026. We've got an enormous array of interesting customer and partner stories for you lined up. I'm really looking forward to bringing them with you, to you, and really enjoying sharing these stories with our customers and partners. It's really kind of, honestly, it's my favorite time of the month and my favorite part of my job to be able to bring these stories to you. Today, we have two really interesting partners. We're going to be talking about agriculture today. Agriculture is an industry we haven't spent a lot of time on with Industries Live, but we're going to talk a lot about what is a very heavily geospatial workload, high compute, high storage, some really interesting use cases that are changing very quickly in the industry, and there's a lot of really interesting things happening. So the conversation today is going to be extremely fascinating, so hang around. If you haven't watched Industries Live before, let's pop the QR code up. Industries Live is our every second week show. We talk to customers and partners about what they're seeing in the industry, what's happening in their business, but specifically looking at it through a customer and a use case lens. It's a really fascinating dive into an industry to get a sense of what's really transpiring. If you click the QR code in the corner, you can register and you'll get your invites on a regular basis, so you can join in whenever you are available and partake in the show. So, Patti, I think it's about time. Why don't we welcome our first partner? I think Matt's been waiting patiently in the background. Matt from Wherobots. Good morning, Matt. How are you?
Hey, good morning. How's it going?
Really great. Matt, many of our people are watching from the agriculture industry and no doubt heard of Wherobots, but perhaps, and you work across lots of industries, of course, but perhaps why don't you tell us a little bit about Wherobots and then also just a little bit about yourself, Matt?
Yeah, absolutely. And thank you for having me here. I'm excited to dive in, talk a little bit more about geospatial, and that's really what Wherobots does. We are the spatial intelligence cloud. So we focus on all things that basically happen on the surface of the planet. Of course, agriculture being a big one of those. The company was founded out of the Apache Sedona project. So if you're not familiar with that, it's basically distributed computing for spatial data. And spatial data is incredibly complex, and I'm sure we're going to dive into that a little bit more. But it makes it very easy and scalable to work with things like satellite images, process that, work with different information about fields or different information for supply chain, all these different facets about how things happen on the surface of our planet, move around, and all that, of course, taking place within AWS. So really, if you think of Wherobots, it's we can handle processing large amounts of data about things that happen on the surface of the earth. So.
Wonderful. It's so great to have you here, Matt. I'm really excited to talk more specifically around the challenges in agriculture, because what I'm hearing from our agriculture customers on AWS is that data volumes are really exploding, and a lot of that is geospatial data in nature. Agriculture, 50% of all habitable land on Earth is agriculture land in one way, shape, or form. So as this data volume is growing, whether it's satellite imagery or drone data or sensors in the field, what trends are you seeing, and how agriculture businesses are challenged to keep up with this growth and trying to use it for AI and other large-scale modeling end user applications? And then where does Wherobots fit into helping to address those challenges?
Yeah, when you think about the entire life cycle, of crop production, going from planning and planting, through growth, monitoring, making sure that you're providing the right things to, the crops that you need, all the way through to harvest and then supply chain and then delivery. It's an incredibly complex system of all the different things that happen. So there's I think a combination of things that take place. Number one is that we've never had more data about, well, the earth in general, but if we're focusing in on agriculture, about this entire process. We can, go from precision agriculture, figuring out what we should plant where and when, how the crops are performing, and monitoring that on a very regular basis with high granularity. We can forecast and understand what we think is going to happen. We can, predict and model when we have things like weather and, different climate events that are taking place, to understand how we should react to that. And then all the way through to harvest, to ensure that, we're tracking where the crops are going to, how they get to the different places they need to go, and all these different kind of components that make up this and get us our food at the end of the day. So there's this huge process that goes through that. And I think what's happened is the sheer volume of data about all these different components has just skyrocketed, right? When we think of big data, I kind of think of it in like two very different ways, especially when we're approaching agriculture. One is like, the field itself, right? If you're thinking about, the tractor moving to and from, understanding and tracking, what types of seeds are going where, getting very detailed information about a very small patch of land, right? Even just a part of a field or something like that. That data and that volume is actually quite complex, and you need to have and be able to measure on a very specific scale, right? You need to be accurate and be able to understand that from a temporal perspective. So while it feels small in, terms of like what we're looking at the earth, it's actually big data. Time and accuracy are really important. On the flip side, when we're looking at monitoring and we want to, understand, okay, what does the crop output look like for the state of Iowa, or for the entire country, or for these different regions globally, that's also big data, because there is a time component. We're looking at different slices of time going over and over from there, and then all the way through to, the sheer scale of the volume there. So I think these are some of the challenges that I see within agriculture, is like just, big data looks different for different parts of this process, but it's we need the system to do that. And Wherobots helps to do that, from understanding things like telemetry, movement, temporal components, and ensuring that you can not just work with that data efficiently. And geospatial data, for anyone who doesn't know, is I'm talking about images and pixels, like literally from a TIFF file that are measuring our planet, all the way through to detailed, precise coordinates that you need to measure based on that change based on where you are on the earth, and then all the way up to how can we handle that to do the processing, the AI and the machine learning, to actually figure out and forecast going forward. So there's all these different pieces, and we've really tried to build a platform that can handle both those small and big cases, and then the big and wide cases, when we look at the surface of the planet.
Thanks, Matt. I had just a quick question, or just for everybody who's watching, by the way, please engage with us in the chat. We're monitoring the chat, and please, feel free to speak out. Love to hear where you're calling in from. And Matt, I'm super interested in what you were just saying. Lots of people talk to me about data lake houses, and I'm interested specifically, you talked a little bit about just the sheer volume of data that spatial use cases create. But I'm wondering if you could just sort of dig in a little bit further on what is unique about spatial data lake houses, and what is it that, what are the unique considerations that mean that we have to think about them differently than we would in traditional sort of enterprise data lakes? Yeah,
spatial data is kind of, I really want to say it's just now making its debut in the lake house. Iceberg, the V3 spec, that's some of, a big chunk of our team actually put a lot of effort into pushing that out as of the middle, I think, summer last year. Other kind of lake house formats are supporting, the geography component. But we kind of look at it a few steps further. When I say geography or geometry, that's something like a point line or a polygon, right? A line being a road, or, a polygon being a building footprint or a lake or a field boundary in this case. When we look at other types of spatial data, there's actually two other components that are pretty, I would say, uncommon in the bigger lake house architecture. The first one I mentioned is imagery, right? Where, if you think of a satellite, it's literally taking a picture of the earth, and the picture there is pixels, and the satellites measure lots of different things, from They look at the actual RGB values of the Earth. They can look at near infrared. So we take all these different components and we can actually study them, understand vegetation values, find very specific crop types. You can even get super specific and understand if there's, potentially identifying, pests or plants that are invasive and causing problems in the field. So, that a pixel doesn't really, like, when you think of like data and rows and a lake house, you don't think of like an image and a pixel there. The other type is actually climate data, which is, basically an array-based format. So satellites also measure things like, wind and water, moisture, soil, and weather, and all the different things that are happening from our climate globally. That's really stored in like what's known as like what we call an array-based format or a grid format. So it measures it and averages it over like a certain amount of decimal degrees or something like that. And of course, we want to know how that changes over time. So you kind of get this data cube that's more like an array-based slice. Again, it's akin to a raster or pixel because it's kind of tied to a grid, but it's another kind of format you have to kind of account for because you want to slice and dice it in very specific ways. So this data gets quite large. I mean, we're talking, if you look at just the imagery alone, you're looking at petabytes of potentially imagery data. The storage gets quite high, so it doesn't kind of fit into your normal database architecture. And one thing that we've really focused on is creating remote references to that, right? The whole value of the lakehouse is I can store data efficiently, scalably. I can move it through different forms and things like that. And then I have this reference that can reference down to that. So what's unique about what we've done with on AWS with Wherobots is be able to create remote references and say, like, I just need this part of the image right now. I don't need, the entire continent, or I don't need even the entire country. I just need, this specific area there. So that allows us to scale and move very quickly there. Same thing with just your points, lines, and polygons. If we think of a GPS track and moving through that, you want to be able to slice and spatially reference what you need to look at different times. And that's where we get these like really big boosts in performance gains, is being able to do that and then serve, really well-designed data outputs that you need to go from there. Okay, where did the tractor go through the field? Did it miss any areas? Are there any areas that we need to water again? How are the crops performing? All these different things that you can kind of go through there, through to, like I said, are the crops healthy? What is this expected yield? What can we look at from there? So it's all about getting these right pieces in place to scale it effectively.
Matt, that's really amazing. And I love how the Wherobots platform is really kind of taking away the undifferentiated heavy lifting of geospatial compute and analysis and processing. And I understand like your platform integrates very easily into AWS data storage services, into many of our common data platforms that our customers are using, and that on the other end, partners like Felt, who we'll hear from later. Can you actually walk us through kind of the typical end-to-end workflow that customers are using Wherobots for, and how they're really leveraging Wherobots on top of their AWS infrastructure to achieve better price performance and cost savings for these really large-scale geospatial analyses?
Mm-hmm. Yeah, absolutely. So most geospatial workloads include some sort of internal data to your organization, right? Maybe, you're, actually putting, sensors on, the equipment that's going on the field, and you're receiving these lat-long pings that are coming back. You might also integrate with public data sources. One of the great things about geospatial is it's really well supported from lots of different agencies. People like NASA and the European Space Agency are sending satellites into space, so we get a lot of rich information about our Earth. So you might integrate with a public data source. AWS is a very good place to actually go out and get that data. You host it, you make it available to read in, so it's kind of already there for you to integrate with. And then there's other data sources you might bring in. Maybe you're collecting data from a third party, but you have this kind of list of data sources you need to bring in on a regular basis. So that's step one. The next step is to really pull that and unify that. Like geospatial, if you work in the space, it has many different forms of data, well over 250. If you look at it from very different formats, and there's lots of different reasons for that. So instead of having all these different formats, you want to unify them in one single layer, and that's that first step that we kind of bring in. That's where we integrate into the lakehouse. You can load that into your S3 storage, and then we bring the Iceberg catalog that sits right on top of that. That brings in a lot of performance boost. Now, for the processing steps, that's really where we have engineered a scalable compute engine to handle those different pieces. So I mentioned earlier a little bit about this like remote reference to a raster. Like you don't want to load extra data in memory if you don't need to use it. And we can use, a spatial arrangement of the data to really read just the pieces we need and make that very scalable and efficient. A lot of our customers see like a 20 to 60 times performance boost, depending on the operation that does that. So all of those pieces that are engineered all the way down to the data level, the compute layer, all these different things allow us to produce that scalably. And then the final outputs that people produce are either data sets, maybe it's data that's being fed to an API, maybe it's data that's being fed up to a map application like Felt. All these different pieces can kind of start to integrate really nicely to produce what you need to go for, because it might be an API, it might be a spatial application, or it may be something, like actually integrating with a large language model and producing data to be consumed there. So it allows you, the really big problem is that middle layer where you're doing this like kind of complex processing, like maybe it's referencing the raster data to do detect different areas, finding different features or whatever that might be. That's where it's traditionally been a bottleneck, and we really focused on solving that really efficiently, and then of course integrating on both sides of the pipeline.
Mm-hmm. And that it's your raster flow product, right? That you simplify that process for your customers.
Yeah, raster flow is really focused in on handling the imagery component, right? So imagery, if you think of any sort of, like a picture, right? You can detect things from it. You can kind of scan it to say, is this a dog or a face or something like that? We're doing that just instead of looking at it face on, looking at it from the bottom down. So we can detect things like canopy heights. We can actually understand the different layers of the imagery to understand, are these crops healthy? Are there any issues there? We can kind of understand moisture content. You can even get into climate use cases. There's a whole set of different things there. Traditionally, again, that's just kind of been a something you productionalize a model on and kind of like use a ton of computing resources just to kind of move it through quickly. We have really focused on creating that to be a scalable, distributed engine. There's a lot of different pieces there if you want to measure over time. And the satellites, as advanced as they are not perfect because they're scanning not in a perfect square that you want on the Earth. They're moving at different diagonals. There's, of course, things like clouds that get in the way. So there's this whole pre-processing step that handles how do we unify data from different time slices? How do we create these things called mosaics that are unified imagery? How do we stack them in different layers? And then we use a lot of those really scalable data structures I mentioned earlier to make that whole process very smooth. So you can say, instead of, oh, I'm going to run this model once and it's become, too cumbersome or too, expensive to run, we make it very scalable so you can get these insights on a, regular flowing basis that comes through.
Yeah, I for one am very much a visual learner, and I've seen this really nice kind of video that illustrates the raster flow process. Do you want us to cue that up? We can show it and you can talk us through it.
Yeah, so if you're kind of understanding how we scan the Earth, right, there's lots of different satellites that are measuring and different things, and there's lots of different things we want to measure. The biggest first challenge here is the preparation of the data, right? These are not smooth tracks, so you can kind of see how we backfill this with other data, maybe a recent pass, and then we stack them to get this temporal view. You don't care about one specific time. You want to stack that and move it through very quickly. Then we bring in regular models that are well vetted. Different industry experts have developed them. This is one that measures fields of the world that was developed by the Taylor Geospatial Institute that we partner with them to onboard and make that very scalable to detect field boundaries. Now, of course, an image isn't very useful in an analytical workflow by itself. So we actually turn those into geometries and polygons so you can do and ask spatial questions about intersections. You can average and aggregate data there, and then you can create reports like what is the output by state or by county or by farmer or whatever that might be. And then you can serve really compelling visuals like you're seeing here with Felt. You make that very efficient to analyze and discover and share. Right, we want to move from scattered imagery all over to insights that are coming out visually and make that cost effective and scalable and fast. That's really the goal of what we're trying to do here. So that's looks like I timed that pretty well with the end of the video there. So that's kind of what we do from there.
That's really great, Matt. Thank you. That was really puts a bow on it. So yeah, awesome.
So just at the end there, you showed this this nice map with Felt, who we'll be talking about in the next segment. But I understand you've got like a really nice case study with a customer called Leaf Agriculture that Wherobots supported and Felt also supported. So you have this kind of end-to-end case study that I love. And many of our enterprise agriculture customers, that they're using Leaf's platform today. But as that platform grew and the data volumes grew, they were running into some processing challenges. Can you tell us more about the challenges that they were having and where Wherobots was able to help?
Yeah, you really hit the nail on the head of, they saw the data volume increasing, significantly, right? In terms of a lot of the different customers we talked to, and Leaf was a very good example of this, the more data that's coming in, some of those original processes start to become cumbersome or slow, or maybe start to balloon in terms of cost and scale like that. So they kind of saw, an exponential increase over the past 3 years in terms of all the data they did. They needed to rebuild their pipelines, do all this data processing to kind of make that scalable and efficient. So they needed a better way to get their customers fast information. They kind of serve that via a unified farm API. So, the temporal updates, the frequency of the data, all those things are very critical to what Leaf is doing. So Leaf partnered on the data side with Wherobots and AWS and deployed this modern geospatial stack from the spatial lakehouse, integrating raster data, all these different pieces that help them connect and then process and then serve that data. So they used different components like Wherobots DB, which is the spatial lakehouse I've been mentioning. Some of our raster flow and AI features that you can do inference, and they can unify some of the sensor data that they're collecting, the satellite imagery, the sensors being that really small focus data, but still complex, up to the satellite imagery all over the earth. And then what allows them to do is serve that final output in a very developer-friendly workflow using SQL and Python for precision agriculture. So the outcome, or kind of what happened for all of this, they significantly reduced their processing time, their overall cost of ownership for that spatial system went down, and they can scale to millions of acres and go much wider, and just do that on the same platform. One of our most important things is, if you start with one geography, maybe you're studying a province or a state or an area, if you suddenly want to go to the country or the globe, that makes it very easy just to step up by just switching to another compute layer. So they can power fast and actionable intelligence now using Wherobots and AWS to really serve that out to their customers at scale.
That's awesome, Matt. I'm interested just in a couple of things that may have jumped out to you as you've been through these customer journeys. Like, if you had some advice for a couple of agriculture customers that are sitting on massive geospatial amounts of data, like what would be the couple of tips that you'd give them as to the sort of secret sauce and success for them?
I think the biggest thing is kind of understanding, what are the insights you want to draw out of that. If you kind of start from the question at the beginning to say, I really care about high frequency of updates, or maybe it's, I really care about detecting and finding these things. I think connecting it to like what's happening in the business, I think it's a kind of a very general tip, but you can design backwards now very efficiently to do that. And that all kind of fits into this, kind of scalable, lake house sort of architecture, creating, identifying the data sources that need to come in, both internally, externally, from public data sources, from private data sources, and then understanding how you need to process that data, be it imagery, whatever that might be, and really put all that together in a very efficient flow. That's like the design step. It seems like a trivial one in some ways. You're just like, oh, I want to, get the images out and get the polygons and do the thing. If you can really design it to match the output, and I think what I see our most successful customers doing, to say like, we're serving this, via an API. Maybe it's, using it in a map discovery dashboard, or maybe we're serving, and pushing this out to data providers for data science or machine learning upstream. Creating that really solid, data engineering or data architecture is probably the most important step. And if you can do that, you really have to rely on a platform that can scale efficiently, and what's going to work as it moves through. That's really what we focus in on. So you don't have to worry about that part. If you can design that really well, I think that's a very good way to kind of approach things. So nearly every time I talk with customers, or understand that, it's like, what are you trying to actually get out of it? And then we can design and work backwards from there.
Work from the business case backwards is often what I say to customers. It's fun to tick around and experiment, but at the end of the day, the solid foundations of the business case really underpin the success, for sure. We've just got a couple more minutes, Matt, but it certainly wouldn't be right of me if I didn't sort of bounce it back to you and say, like, AI is just really transforming so many industries right now. And, when I think about hearing you talk through just some of the use cases earlier in the discussion, so many of them are very compelling and very interesting, but I can certainly see where AI is going to have an influence on a number of them. Just from your perspective, I'm just interested in what you're seeing in the industry and any sort of thoughts you have looking forward about 2026, about what AI is going to mean in terms of workloads for agriculture, and just any observations you have there.
Yeah, there's three big ways I see it kind of impacting. Number one is, geospatial has been, integrated with AI for a long time. As it relates to agriculture, some of those things like, looking at an image and detecting, understanding crop health, right? A very, a core use case. And that is all, understanding and processing images, building models, doing all these different pieces to get that output. So that's probably one. It's like, we know that people want those insights on a frequent basis, and they want a low cost of ownership to do that. You don't want to have to build a kind of gargantuan system to even, make that happen. So that's like what we're really focusing on with raster flow. The second part is also kind of analysis and discovery, and kind of understanding what's possible. We've added some different pieces with like an MCP server where you can actually go in and ask questions. If you're not from the geospatial world, you can kind of ask a question like, I want to understand vegetation, and vegetation health. And we've been doing some different things to say, oh, well, that's a NDVI analysis. And if you don't know what that is, that's okay, because an MCP can assist you and actually show you how to structure that, connect to open data, and actually run that to help you get that information out. And then I think on the third one is LLMs are becoming an increasingly popular way for people to ask questions and discover information. I think that's probably the next big thing over the course of the year I'm going to be trying to watch, is to say, okay, how do LLMs interact with these outputs of spatial data? And I think by having a clear data process, you can really structure the data, bring it up to the surface, and make it very consumable by the LLMs. Their language models are not processing engines, right? So we need to make our data match the inputs for the LLMs, so people can ask more questions about space and time and all the things they want to discover.
Matt, fantastic. I know we're just about at time, but like, if people want to engage more with Wherobots and understand more about your business and learn from you, like, how can they connect with you?
Yeah, obvious one is go to wherobots.com. If you're on AWS, you can start Wherobots in the AWS marketplace. If you're interested in kind of learning and getting into the weeds of this whole kind of data architecture process, we're running a data engineering cohort-based course. I'll be instructing along with a few others. So it's live labs. You actually go through the different pieces. We'll go through a geospatial medallion architecture, and you can actually go through these different pieces to actually develop that. So you can go there. You can go to wherobots.com/learn and get signed up. And then if you want to get started on the AWS marketplace, go ahead, start running some different processes, work with spatial data, and yeah, get started.
Awesome. Well, thank you so much, Matt. Really enjoyed the conversation. It's amazing how quickly it goes. I feel like we could talk for another half hour. Thank you so much for joining us, Matt. We're at the halfway point, so we have another episode coming up straight after this. Patti, thank you so much. Any last words from you before we wrap?
I just want to say I'm really, I feel like we're really privileged to have you on here with us, Matt. You are a thought leader in the geospatial community, and I love that Wherobots is really pushing the state of the art on cloud-native geospatial compute, because that's what's really going to set our customers up for success for AI modeling and any large-scale processing workload at scale.
Yeah, thank you so much, both. It's been great.
Nice. All right. Well, great to see you both. We'll be back in just a few minutes for the second half of our episode. Again, thanks so much, Matt. We'll see you next time. And thank you for joining us on Industries Live. Hang on, and we'll see you again soon.
All right. Thanks.
Good morning, good afternoon, good evening, wherever you are in the world, and welcome back to Industries Live. It is the second half of our show for today. It is our season 2 premiere again, as I mentioned on this first half, if you were on. It is great to be kicking off 2026 with Industries Live again. We celebrated our 1-year anniversary at reInvent with the live show. This is our 1 year for the streaming show. So we're very excited to be back, and we have a whole raft of interesting customer and partner stories that we're going to share with you in 2026. Welcome, Patti. Very nice to see you. My name's Michael Schmidt, by the way. I look after industry partnerships here at AWS. Patti, why don't you introduce yourself?
Sure. Hi, folks. If you're just tuning in, my name is Patti Carroll. I lead our solutions and go-to-market program at AWS for agriculture. So I'm very excited today to be focused on the agriculture and ag tech industry. And our theme is really looking into the big data challenges, and particularly geospatial data challenges. In our first segment, we had Wherobots on, really looking at the back-end data infrastructure and how we're really scaling up and creating that foundation to build these AI models and applications. And now I'm really excited to have Felt, our partner Felt, on, and Jaime Sanchez from Felt, talking about more of the end user applications and how we're really scaling that interactive capability of really asking questions of the data and generating insights in real time.
Yeah, me too. Before we get to Jaime, I'm super excited for the second half of the show, and they naturally fit together. So if you enjoyed the first half, the second half is going to be fantastic. If it is your first time at Industries Live, as I mentioned before, Industries Live is our bi-weekly show where we talk to customers and partners about what they're seeing in their industry, what the industry dynamics are changing, what's happening, what they're hearing from their customers, and really their observations about the path forward and what does 2026 mean for them. And we intend to put it in language that everybody can understand and gain some insights for not just for the industry that we're featuring, being agriculture today, but also for adjacent industries, and how some of these workloads might transcend into other parts of business. So very excited to have you on. Actually, we'll just pop up the QR code for registration. If you're interested in joining us regularly this year, we would love to have you on. Please register with the QR code, and then you'll get regular invites to join in, and you'll get a sense of what's coming up in the shows ahead. Okay. I'm very excited to invite Jaime to the studio. Jaime, how are you today? Joining us from Madrid. I should say that Patti and I are both on opposite sides of Seattle, here in cool, slightly overcast Seattle, I would say. You're joining us from Madrid. How's the weather in Madrid today, Jaime?
It's actually a bit cold today, but otherwise we're doing very well. Thank you for having me, Michael and Patti.
No worries. Well, Pat, Jaime, why don't you tell us a little bit about, let's start with a little bit about Felt, and then maybe just introduce yourself and what you do at Felt. That'd be fantastic.
Yeah, so I'll get started with Felt. So Felt's a modern GIS and mapping platform built with AI from the ground up. And I like to tell about what Felt is with a little bit about the origin story of how it became a thing. And our founding team was finding themselves very much so in the battles of government work in planning departments in many cities across the world in different jobs. And what they were seeing often it was that teams and departments here were collaborating with mapping software that was not at the current with modern standards. And even in some cases, they were collaborating with teams that were actually using paper maps to draw a bus route to define if this is the way to create something like this. And out of that, Felt came, and I like to describe Felt as if think of it as a Google Docs for maps. You're able to share a link, everyone can come in, and we can see each other as we're collaborating, adding, editing, and then publishing applications with maps. And myself, Jaime Sanchez, I lead our partnerships team. I've been working with Geospatial for the past 10 years, and my focus is really getting to where our customers' data is, be it in AWS, be it in Wherobots, and in connecting to those data warehouses and those lake houses, so our customers don't need to move their data. It stays where it is.
Amazing. It's so great to have you on, Jaime. I'm excited to talk more about Felt and how you fit into the space of solutions for agriculture. From my perspective, we're seeing more teams within these agriculture companies that aren't data scientists or data engineers, but they need to work from location data, and they need to make decisions in real time, whether they're agronomists or sales teams in the field, operations managers. But most of these people, they don't have GIS degrees or deep experience with geospatial data analysis and visualization. Can you talk a little bit around like the bottleneck that you're seeing in this industry and similar industries, and how Felt is helping to democratize access to geospatial analysis for less technical teams?
Yeah, I think the overarching trend that we're seeing in geospatial and in the industry is that traditionally it's been a role that only GIS practitioners do. And for the audience, GIS, that don't know GIS, that's Geographical Information Systems. Um, and what we're seeing is just like there's all these other personas. There's data engineers, like Wherobots audience and what Matt was talking about. There's data engineers, there's web developers, and there's just like business users that want to get access to geospatial analysis but can't because there's either a legacy software that's prohibitive in licensing costs, or it's just something where it traditionally require a lot of like skill sets from uni. And where Felt is really thriving is in that sweet spot of democratizing maps for everyone, and connecting it to like a little bit of what Matt was saying before with Leave, one of our joint customers. It comes really to fruition there because they're a very well-versed technical team. They're really good data engineers, and they are basically their use case is that they're a farm data API. They connect tons of different data sources into one place for their customers, and which then trickles down to helping farmers with soil, nutrients, pH, moisture. It's really defining how farmers do precision agriculture. And for them, grabbing a export from their warehouse or from their lake house, i.e. Wherobots, that's bigger than 1 GB, and trying to map that was a challenge. And this is where Felt came in and was able to take that easily and render it in a map that then can be shared across the organization by not GIS experts, by business users, web developers, and data engineers that are just starting to get into the geospatial analysis world.
Nice. I guess, Jaime, I'm interested in some insights from you around, you have tight integration already with a number of AWS services, S3, Bedrock, Redshift, of course, and you also integrate really closely with organizations like Wherobots and their solutions. I'm interested from an integration point of view, like, tell me a little bit about that and why that matters for lots of other AWS customers that have already got an enormous amount of data on AWS. Tell me a little bit about how that integration works and some tips from yourself about what the secret sauce is there.
Yeah, I think we can date this back a little bit to the early 2020s when we started ideating the idea for the company. One of the biggest things that we saw from legacy software or legacy solutions is that they weren't connecting to where the data was moving to. That's S3. I think most of geospatial data out there in the world is in S3. And so for us, being able to integrate with that and to the whole ecosystem of Redshift, of Postgres, and even Wherobots now was detrimental, or sorry, was pivotal to our strategy. So the whole data gravity problem, where you don't want, as an institution within the company in IT, for example, give access to your data to other SaaS software. So being able to connect natively to data was key to our strategy. And this worked out really well because in the end, you're solving a very big pain point for our customers. So that's on one end, on the data part. But on the AI, since I told you when we started Felt, LLMs were like at the beginning. The anecdote there was that the first LLM we used was to basically help customers geocoding, which is when you take an address and you transform it into a lat long. This is a notorious problem because since it's a text field, it's a lot of like just gibberish out there and not formatted well enough. So even then, the LLMs from 2021 were good enough for formatting that. And then we've added more functionality. And Bedrock has been really awesome because of sovereignty and because of privacy. So being able to deploy Felt inside a VPC and using Bedrock with models that run locally to that VPC has been super good for us and for our customers in terms of how they deploy these things. So it's accelerated a lot of the business that way.
Would you have some advice for customers who are thinking about, like, based on the experience you've had with that journey and in terms of making those integration points more seamless? Like, what advice would you have for customers in terms of how they see their data and how they?
Yeah, I think we scratch our heads a lot with where to start in terms of integrations, and definitely doing research on where is most data, and doing customer service and customer interactions for understanding that. But on the AI piece again, we were like hitting some roadblocks in like how do we develop something that's like increasingly changing all the time. And I think part of the design process in our team is to plan that the LLM is going to be improving in the next year. So if you take that into account when you're building a coding agent or something like that, and it's not working, have some room for it to work next year, because the LLMs continually continue to improve. So that would be my advice. Bank on the
Very interesting.
technology improving.
As engineers, we're not trained to think about what might be or what we're trained to think about what is. So that I just think that's fantastic advice. I mean, really, I love that.
Amazing. I'd like to maybe take us back to the agriculture use case. We were talking a lot about precision agriculture, and I know you've got some case studies around carbon farming. These are just a few of like many kind of common use cases that are really needing this type of solution with this interactive mapping across the industry, across, from startups, enterprises, public sector, as you mentioned in the beginning. I was wondering, Jaime, if you would mind just kind of walking us through a scenario where Felt has helped teams visualize and act on complex data very quickly with Felt maps, and maybe like think through how an agronomist or a sales team could make a map or use this map to make faster decisions without needing engineering support on the back end.
Yeah, actually, it's a good moment to queue up the video as I talk about the Leaf Ag use case, and I'll show you a couple of just screens of what they're using Felt for, from analyzing large amounts of raster data, as you're seeing here on the screen, to then analyzing actual like how the tractor moves across fields, which is this view over here, to understand. This is exactly precision agriculture, and what they were having the problem with is like this is highly detailed and it crashed legacy desktop GIS systems. So being able to drag and drop a CSV or connect an S3 bucket into Felt and just have a map like this was a game changer for them to create also applications like this one. And then I think the real value for them comes across when you start to like ask yourself, what can AI do to help us with this? And I'll showcase another of our customers in agriculture called Indigo, where they do carbon farming mapping. And this is another map that they built. But here's the crux of it all, where you're able to prompt our Bedrock, which in the background this is Anthropic, to create experiences around the map. And this is, I think, when you ask our customers how we save them time, when you ask a business user or maybe a data engineer that doesn't know a lot about geo, how we help them, this is how we save them time. And in this scenario, we're doing a crop irrigation calculator. We loaded some layers into the map, and then we're asking and prompting the AI, hey, can you build this extension to the map where for this specific crop, calculate how much irrigation it needs. Or another scenario where you create stories, story maps, or in this one, deforestation over time. So these are a couple of screens of how folks are using Felt, specifically in the agriculture industry.
Thanks, Jaime. No, those are really great visual examples. It was all, you even touched on forestry there, which we haven't talked much about, but forestry is a huge part of agriculture, and there's a lot of unique use cases there. So thank you for sharing that. And I really love how these maps, they're also like very interactive. So in real time, you can add features to the map, you can ask questions, you can have other people in there commenting at the same time, right?
Yeah, no, that's one of my favorite functionalities about Felt is when I joined, and I've been in Geospatial for more than 10 years, and a lot of the times it's creating a map and it's sharing with a link. In some platforms I can do that. In other scenarios, it's screenshotting and putting in a presentation. But what really was like awesome was being able to share a map with for example, you, Michael and Patti, and having you see my cursor as I move around the map. I can be in Italy while you're in Greece in the map, and you're adding contextual layer there, and I'm adding contextual layer here. So that hasn't really been done before in mapping. It's been maybe done in design with Figma or in productivity with Notion, but that's something that Felt is building a moat on, which is really exciting. And then the interactivity part, a lot of folks that maybe use Leaflet or Mapbox to create a mapping application, what they have to do is use a library and create a lot of that content themselves. And what we've been able to do is train Claude or Anthropic really well to use our SDK to build interactivity. So the moment a business user, as they always do, ask for a button that does X here, I can just do that and prototype that very quickly with the LLM, which again is saving a lot of time for our users.
Even like an agronomist maybe that's sitting down with a farmer, right? And he's showing them the map, and the farmer asks questions like, well, that isn't on the map. He can like kind of create that really quickly. Like they need that button or they need that analysis. And he doesn't need to be, or he or she doesn't need to be technical in the engineering or data science capacity.
Yeah, and Leaf, for example, they have very big, important customers like Bayer and Syngenta. And whenever they were like, hey, there's an issue with this like underlying data source, what's going on? Being able to quickly send a link and a comment to where the actual feature is wrong, it is saving them time, and it's just also a nice experience if you're a buyer and you're paying all this money for software, that you're able to get to the problem really quickly. So the user experience part of Felt, the design behind it, is also one of the strengths that it has, I would say.
Where are you seeing, Jaime, where are you seeing the most traction and the most success in terms of use cases in agriculture? Like which are the top two that you're getting the most demand for, that your customers are pushing you the hardest for?
Yeah, so precision farming is one where we're being pushed the hardest because of how large the data is, and we're lucky to have partners like Wherobots, where we're able to like, yeah, they do something that's really powerful, which is doing the raster and the vector join at a scale that it's just cheap and also fast. And so that's one of the biggest use cases, precision farming, making sure that we know when to water a plant, or depending on where it is exactly, measuring NVDI, soil nutrients, pH. That field is big. Then a second one that I would say is the Indigo one, which is carbon farming and sustainability tracking. They also have a lot of raster imagery requirements. And then the other one is harvest planning and yield prediction. So it's like, how do you run more models across all the fields based on the crop, and seeing how much yield you're going to have, again using satellite imagery for that analysis. And then across all of them, all these use cases, the missing piece was the collaboration part between the data engineer, the business user, and the web developer. Having those three things connected into one platform was the thing that we were seeing that was missing.
Interesting. I mean, obviously, for all of those use cases, there's obviously extremely strong business imperatives for all those, and ROIs kind of goes without saying. Perhaps another question I had for you is, are you seeing anything in terms of other industry adjacencies where you're seeing these use cases lip into other industries that are starting to be interesting, or you're starting to see some demand from other industries that are interesting?
Yeah. Well, we traditionally have seen a lot of just overall in climate tech. These are teams that are new and are fast moving, and they're adopting new technologies, and so they mostly have their data in, for example, S3 or Redshift, or in all these tools that are modern, and that we're seeing a very big adoption. But in general, it's a very horizontal play that we have. So one adjacent industry is insurance, because a lot of the insurance, they insure crops, and that's a very natural progression there. But we're also seeing in mobility, in financial services, a lot of success in implementations.
How interesting. That's that's a very I have a lot of partners often ask me, oh, how can I get into different industries? And I think that some of the use cases and having being kind of successful in one industry can often lead to those adjacent opportunities organically, rather than trying to spread yourself too wide. So, fascinating story. Sorry, Patti, did you want to ask a question?
Yeah, I've actually got a follow-up question. This is kind of coming in from one of our streams, but I think it's a good one to hit. When you talk about geospatial and GIS, there's one name that everybody knows, and a lot of our customers use Esri and use ArcGIS, and it's got its place. I've come to realize, working with my customers, it's not the right solution for everybody. But Felt, you kind of operate a little bit differently, and you serve a little bit of a different market, but you also very easily integrate with Esri ArcGIS. Is that right? Can you tell us a little bit more about how Felt plays in this space with other GIS?
Yeah, it's true that when you're trying to disrupt the industry, you at the first iterations of it, you do connect and you do coexist. So right now we have a connector because we know that a lot of these customers, a lot of people in agriculture are gonna be using a Small World or Esri or other tools. So what we have is a connector that can pull data from those sources and really help you just save on overall licensing costs, because then you don't have to get, for example, for app development or for web app consumption, you don't have to get that many more licenses with your existing tool, and you can just plug in Felt to kind of democratize and build applications on top of that. Having said that, we do also compete in some realms. So we also are a GIS platform, and we at that time, depending on the industry and depending on the use case, can compete with them in that case.
Absolutely. Yeah, I've seen a lot of success, particularly with our startup segment. I had a great opportunity last year to work really closely with AgTech startups on AWS, and I felt was a little bit more accessible to the data scientists on these teams that really, need something to kind of spin up quickly, and they don't have a huge budget. So I love that Felt really kind of helps us address this solution in this space alongside Esri across a wider market range.
I had a more forward-looking question for you, Jaime. I know we're getting towards the end of our time together. You wouldn't be Industries Live if we didn't talk a little bit about AI, and we've sort of threaded it through a number of the different questions. But I'm interested from your point of view, and we talked a little bit about this with Matt before. What are you seeing in terms of the direction of the industry, the opportunity for our mutual customers, and what are you seeing as the sort of unfolding use cases that AI is unlocking in agriculture for you? And I'm just interested in a few comments from yourself and observations that you're seeing.
Yeah, that's a great question. Looking forward, with the in the backdrop, what I said before about thinking that the AI will improve later, it's something that we have very present at Felt. Probably for 2026, what we're seeing a lot is just the agentic loop. How do we play into that whole world of things? Like already today, you can go to Claude or to ChatGPT and ask, hey, can you use Felt to do X or Y? And already Felt's SDK and Python library is so well documented that you can actually get stuff going. But in 2026, we're thinking about how to close that loop even more. Maybe it's an MCP server, maybe it's a skill. We're right now in the process of building that part, but in the end of this queue or in the beginning of the next queue, we're going to have something to announce along those lines. It's like, how do you bring the agentic loop with Felt? Is it starting from Claude and from the LLM providers user experience, starting from there, or is it something that starts from the actual Felt platform inside? And a quick also shout out to Wherobots, because they recently released an MCP server, which is, I've tried it and it's really cool. And it's something where you can just query with natural language and get SQL written, not only written, but actually iterating into something. And that's already something that we're working on, maybe doing more integration with as well. Like, what if our agent called an MCP server from Wherobots, as an example, to bring data into the platform?
Yeah, I think one of the real strengths, obviously, of agentic is to be able to integrate, diverse data sets and take on autonomous tasks. And, I think one of the things you've said a couple of times today is to know that somebody once said this to me, and I love this, I'll quote this back at you, is to say that the AI tools we have right now are the worst we'll ever have. So it's only going to get better from here, right? So knowing that, thinking about, that things are going to evolve and things are going to get better, thinking through an agentic mindset and thinking about composable architectures through agentic doesn't necessarily mean you have to be in a utopian state tomorrow. Experimenting, having human in the loop to be able to ensure that you're making the right decisions and that you're having good guardrails around your agentic architecture is the way to go. And looking for the opportunities where agentic can actually kind of differentiate yourself in the future is kind of the baseline. But this is going to be a very exciting year, and I think that's for a lot of customers and partners, it's as much about starting to think about what role agents might play in your workflow as and where that might get to as anything.
Yeah, like I think the metric for success I think personally, but also in general for the industry is be like, can you write a prompt about creating a map and then going to get a coffee and then coming back and the map's created with all the data, the style, and published into a URL that someone can consume. That I think that's the holy grail. Once you do that, then you're freeing up so much more time for deeper analysis and for actually adding value to your business. So that I think is something that I'm going to be looking in the lookout from tools like ours.
Nice. Well, Jaime, it's been great spending 30 minutes with you. We had a really interesting discussion, and thanks so much for being so candid and sharing your own insights and thoughts with what you're seeing in your business and in the industry. I think we had a slide just in terms of maybe you could just tell us a little bit about if we want to know more about Felt, how we engage with you and how we find you.
Yeah. Well, the tool is free to use, so there's a free trial if you want to use Felt to create maps. And then if you want to actually have the full experience with someone from Felt to guide you, there's of course a way to book a meeting with us and get a full demo of the platform. Again, we would love to show you how your data looks inside of Felt and how you can create apps and build maps and dashboards in minutes, not hours. So thank you for your time today and for your attention.
I mean, I really enjoyed the conversation. Patti, any other last thoughts, words from you before we wrap?
Just maybe like an extra plug. Felt, you've also got a lot of wonderful demo videos and content on YouTube, as does Wherobots. So I know we covered a lot of material in a short amount of time, but anybody that's listening that's like really interested, there's a website, but I found a lot of value in kind of looking through your YouTube videos there. But thank you, Jaime. It was really great to have you on, and I'm really excited to see what we can do together for more agriculture customers in 2026.
Awesome. All right. Thank you for having me, Michael and Patti.
Awesome, Jaime. Thanks so much for joining us. So we're about to sign off from Industries Live, our debut first two episodes for season 2, and it's been a lot of fun. Thank you, Patti, for joining me for the hour. And we might pop up the QR code if that's all right. So yes, please provide us some feedback. What do you want to hear more of? What do you want to hear less of? What are the interesting use cases you want to see more featured on Industries Live? We love hearing from you. And we're looking forward to seeing you on our next episode. It's 2 weeks is going to come around really quickly. We have a very exciting program of partners all lined up to join us in 2026. So thank you for joining us for our kickoff of season 2, year 2 in 2026. Looking forward to your company throughout the year. Thanks for joining us on Industry Live, and we will see you next time. See you later. Goodbye, everybody.